Hello, hello. Welcome, hackers. Let's get some waves in the chat, maybe, if you're tuning in today. We're going to be learning about how to fine-tune an LLM, what open source LLMs are, why they're cool, everything to do with all of that. If we can, we'll get onto RAG, which is retrieval augmented generation, which is like fine-tuning, but not the same. And we use them for different things. So we're going to learn about that too. Welcome, welcome. We've got some highs. That's super cool. Super cool to have you. Let's give it a few minutes for people to join in. In the meantime, tell me how your day is going. I think this is the last stream for day 2 of Global Hack Week. So tell me how day 2's been. Have you got on with some challenges? I feel like it was a chill day, so lots of challenges to do. Tell me about all of those. Also, if you want a fun little thing to talk about, I'm drinking orange juice. No, sorry, apple juice, but I think orange juice is better. Give me your opinions. What juice is the best juice? I want to know. By the way, that's not relevant to what we're doing for the LLMs, but juice is good. Keep hydrated while you're hacking. Keep hydrated, super important. I don't have any snacks with me either. Normally I have snacks. So I recommend getting yourself some snacks while we're waiting for people to join in, and then we'll get started probably in like about 1 minute. So make sure you're ready. Make sure you're sitting comfortably. I feel like I'm about to start telling a story. And by the way, if I'm too loud, too quiet, whatever, just let me know. I can see what I can do. But yeah, we'll give it another, I don't know, 30 seconds. I'll put some music on in the meantime. If anyone's got a request for the type of music, I can't do particular songs, but I can do generic vibes. This one is called Feeding the Ducks. If it's too loud, you tell me as well. I'm gonna put it down just a little bit. Hopefully this is good. I like it though. Feeding the Ducks. It's cute, right? Ducks are cute. I'm a big duck fan. There's a hackathon in the UK called the Quackathon. Highly recommend it. It's themed around ducks. It's good. It's good. Pineapple juice. Pineapple juice is good. Oh, yeah, that might be better than orange juice. I'm trying to think what my favorite juice is. Maybe it might be pineapple juice. I do love pineapple juice. Yeah. I don't know what else comes close. I like tropical juice in general, so maybe like, you know, tropical with like papaya, mango. Yeah. Hello. Okay, well, welcome everyone. I think we're gonna get started. I'm gonna throw my screen up on the stream. Gonna mix pineapple, orange, and papaya. I mean, that would be good. That would be good. A tropical mix. That would be great. Hello, hello. Welcome, welcome, welcome. All right, let me throw my screen up. Let's see. All right, there we go. Cool. Okay, we got some more hellos. Hello, hello. No, don't worry. We were just chatting while people were joining up. So you're perfectly timed. You're perfectly timed. Do not worry. Okay, so we're going to be learning how to fine-tune an LLM today. And I'm guessing you mostly all know what an LLM is, but it's kind of okay if you don't, because we're going to go through it really slowly. This is very beginner friendly. What we're going to do in particular is we're going to try and give an LLM personality. And the reason why we're doing it in Open Source Week is because, I mean, it's not contributing to an open source project, but these are open source models that we're using. So something like ChatGPT, that is, or at least most of the models by OpenAI, Definitely the ones that you interact with on the website, ChatGPT. Those are closed, which means you can't, as a developer, access the weights, the parameters, and these are all things which are tunable. These are the things that we train in the model when we're building it. And we're not going to train a model in full today. The reason is because that is very expensive to do. You've probably heard that LLMs cost millions, hundreds of millions, billions for the really great ones. Yeah, we can't do that. Definitely not in 2 hours, because it also takes a lot of time. But what we can do is we can fine tune it. That's basically taking a model that's already kind of trained, pre-trained, if you like, and we're going to say, right, we've got some data. We want our model to be kind of responding like the responses in the data. Let's feed in the data and kind of force it to behave a bit more like what we want, what we expect. The reason for this is because it's super useful when you are, for example, let's say you want to build like a little sales chatbot. Maybe you've got a product that you want to kind of promote, and you want to have a little chatbot that helps, but you want it to be, super respectful, super polite. You want it to always maybe at the end link the relevant bit of the docs for the product that you're promoting or something, whatever, right? But you want some kind of tone or style of response, which maybe isn't normal. Then that's what fine tuning is for. You're basically teaching it style in some sense. People often get ragging or retrieval augmented generation and fine tuning confused. Ragging is basically saying, sometimes our AI makes things up. What if we made it check? So let's say you had documentation for the product, right? Ragging would be, okay, when your LLM is asked a question, it goes and finds the relevant bit of the docs and then quotes it. So that's more about the information and the facts that it uses, whereas fine tuning is not so much about the information and the facts. So if you're trying to teach something, knowledge, right? Let's say, for example, you had an AI that could only speak English, right? Speak English, and you wanted to teach it, I don't know, French. Doing that with fine tuning wouldn't be very effective. It probably wouldn't be very effective ragging it either. You'd want to do that in the pre-training stage. But that's a great example of like what fine tuning won't do, because teaching knowledge, in fact, is pretty hard. We've got a little question. This is perfectly timed, actually. The prerequisites of the current session, basically just Python. It's very friendly. We're going to be doing everything in Colab. If you want to run it locally, you can. But Colab is my beloved. I love Colab. It does all of the hardware and stuff for us. It's entirely free. So basically just a little bit of Python knowledge. And even then, like if this is one of the first times you're coding, this should be okay. It might be a little bit confusing, but you can ask questions and I can do my best to answer them. We'll see. So hopefully it should all be nice and friendly for complete beginners. All right, so like I said, we are going to be doing some fine tuning. Before I get into it, I already touched a little bit on it, but I want to comment on why we're using open source models. Actually, I might pull through some notes. This is maybe helpful. Can I? Yeah, let's do this. Super cool. Okay, here we go. So you can read as I talk. So open source models are great. These are kind of some big reasons. The big one, at least in my opinion, is the customization, right? So if you, like I said earlier, you've got some particular like bot, which is going to interact with users and you want it to work in a particular way, or let's say you've got like a training tool, an LLM that teaches new hires, right, in a workplace, how to use your proprietary technology, right? So it's got to be entirely internal. Then again, you could like optimize it to be like really efficient, so it doesn't have like long and wordy responses. Equally, let's say you wanted to write something that, I don't know, generates articles for you, right? You want it to write news articles. Well, that's a stylistic change, and that's what this is really good for. Lots of people will be like, oh, well, you can do that with prompt engineering, and you can, but complicated prompts, they take a lot of time. They're not consistent, right? So you'll have to keep reprompting it. And they can be more expensive as well. It depends a little bit, but they can be more expensive because if you have longer prompts, there's more processing going on. But yeah, and the other things that you can run it locally, right? So if you had a PC with a GPU with, I don't know, 8 gigabytes of VRAM, would probably be the minimum, I would say. You could run this on your own machine, what we're doing today. We're going to be using Colab. It's got 12 gigabytes, so we're covered on the free tier, that is. But yeah, so this is why open source is great. because we've got access to everything. It's entirely ours to play with, and that's really fun. Today, we're going to be using, like it says here, Phi2, which is one of Microsoft's models. It's pretty small. I think it's like 2 billion parameters. Can I provide the link? I don't have a link to these notes, but everything that we're going to do is going to be on screen, and I will actually share the GitHub link in a minute. I don't recommend that you copy and paste things. I recommend coding along because it helps you learn what you're writing. But like if you want, yeah, and I can also share the actual link to the notebook file so you can view that as I code too. Cool. So yeah, like I was saying, Phi2 is pretty small, 2 billion parameters. We'll talk about what that means. Mistral is bigger, it's 7 billion. You probably can't do that for free on Colab. So if you've got access to like maybe university compute, if you're a student at university and you're like, yes, my university has GPUs, then you can use a GPU from your uni. And so you might be able to use a big one. The other thing is you can do little tricks to use bigger models, even in less, with less memory, but it will take longer to run. So we're using a super small one because we're going to do some training right now in this workshop, which is, I think, pretty cool. So I'm going to throw these out the way, and we're going to get kind of started. So what you need is a Google account. If you don't already have a Google account, sign up quickly. I'm guessing nearly all of you do, so that's okay. A little bit of Python and basically nothing else. There's some optional stuff, but I'm not even going to use some of the optional stuff, so you don't have to. So the first thing that I want you to do is to make a Colab file like this. If you just go to like this link, let me highlight it for you there. So a great question from Wei. So you cannot fine-tune popular models like GPT-4o. No, those are closed source. So all of the big ones are closed source. Let me get, actually, I've got a little diagram somewhere, which maybe will help contextualize the difference between like open and closed source models. I think I have it. Oh, maybe I don't have it to hand. I do. There we go. Okay, right. Yeah, pull through just that. Hopefully this is going to work. Okay, cool. So I've got a little graph. This is a super great resource, by the way. I'll share this at the end, if it loads. My laptop, poor thing, is struggling a bit, so we might have to be patient. But while we're waiting, we can go for questions. Okay, there we go. So this is maybe a helpful graph. All of the closed source models are the ones in red here. So Claude, you've probably heard of Claude, GPT-4, etc. These are all closed source. The best open source ones at the moment, as you can see here, like this is the performance on MMLU, which is a benchmark. It's not the best benchmark. I don't love it, but it's okay. It's good enough. We can see that Llama actually here is open source. This is Meta's model. This is probably the best one, especially when you fine tune it. You can get some really good performance. So your best bet is this. This is actually 405 billion parameters, so you're not going to be able to fine tune it yourself. You probably won't be able to run it locally either. But this one down here, Llama 3.1, you could. And as you can see, like especially with some fine tuning, you could definitely get better performance than GPT 3.5. So it's catching up basically. DeepSeek as well. You've probably heard of DeepSeek. It's another very, very good model, which is open source. So there are like some really popular models that you can fine tune, but you're kind of gonna hit hardware limitations. So my recommendation would be learn on small models because you can learn all of the same stuff on small models. And then on, when you want to start doing stuff with bigger models, that's when you kind of apply to work at companies who've got the kind of funding for that, or, academia as well, have some funding for like GPU compute and things. But yeah, so today we'll be using something that's not even on this graph. It's too low down. But yeah, the best ones out there are like Llama. Mistral's very good as well. DeepSeek is the other popular one. So cool. All right, so hopefully people have managed to grab a Colab. Let me just actually, there we go. Hopefully people have managed to grab a Colab notebook for themselves. If you don't know how to do that, just Google Colab and it will come up. You can also go to this link, this start of it, colab.research.google.com. I'm going to send that in the chat. There we go. All right, cool. And I think nearly everything that we're going to do is going to be in here today. And like I said earlier, we're going to be fine tuning in collab.new, even better. Yeah, that's probably the correct shortcut. Thanks for that way. Cool. So where were we? I can't remember what I was saying. Oh yeah, personality. So we're going to be teaching our AI personality. Phi2 is what we're going to be using. I've also got some notes and like I know quite a bit about LLMs. So if you've got questions about the different like words that I use, I'm going to throw words around like weights, parameters quite a bit. And that's totally okay if you don't know what they mean. You can ask, and I will do my best to explain it in an intuitive way. Naturally, this kind of thing can get pretty theoretical. So I'm going to try and avoid the theory, but I'm going to try and give an intuition for what we're actually doing as well. Cool. So where were we? All right, so first we need to install some stuff. If you are running locally, you are going to need to install Torch as well, PyTorch. It's just called Torch. And I think that will be it. Colab already has that installed, so that's great for us. And we need transformers, which is a library provided by Hugging Face. We use it to load models which have already been made, right? So like I said, we're not doing the pre-training, the actual training for a model. We're not building a model ourselves. We're fine-tuning it, so we're just going to take someone else's and adapt it for our use case. And we get them nice and easily from Hugging Face, which is a really great open source platform that has basically everything that you could possibly want. So they provide this transformers library, which you can use. They also provide datasets, which allows you to manipulate the data that you bring in. We've got a custom dataset, PEFT as well. Yeah, this is going to be how we're actually doing the fine tuning. I'll probably get to that in a bit. Accelerate, I won't go into too much detail on either. This is just like, we're actually not going to reference this really. It's kind of included. It's like going to help us be a little bit more efficient in how we tune things. And we need bits and bytes. Now this one is worth mentioning because it's only available on Linux. There are adaptations for if you want to run this stuff on Windows. There's like an edited version of bits and bytes, which does work on Windows, but it's like third party. I haven't used it. I can't therefore recommend it, but you could Google it and find it and use it. But in this case, we're in Colab. Everything is fine. If you wanted to run this locally, and especially at the end, we're going to make a little Streamlit app. And if you wanted to like do that locally, you're going to need to be in a Linux environment or have like some kind of funky version of bits and bytes. But we're going to just do it through Colab. But you know, you're welcome to have a go doing it locally on Windows. Cool. So we're going to run that. What is bits and bytes though? Oh yeah, sorry. Good question. So bits and bytes is used for loading models for faster inference. So it's using this thing called quantization, where if you imagine the weight of each for each little quick question here as well. I'll jump to this one first, actually. I think so. I'm not 100% sure. I haven't tried. It's something I mean to try at some point, but like because I never run things on my personal device because I don't have the GPU for it. Like I haven't. But you could. I mean, again, like I wouldn't recommend not doing on Colab though, just because of the size of the models. You're gonna have like a big GPU. But you could, like, I would give it a try. So bits and bytes, back to this question. Bits and bytes is for basically like compressing the weights of the model. So when you've got your models, they've got weights, which is basically a little number that you multiply by the input. And this is like, it's basically just a whole load of matrix maths to get the output, right? And these are the weights that we train, right? So in fine tuning, we're adjusting some of the weights slightly. but when they're trained in full, like the weights are what's being tuned through the loss function. But normally, at least in Phi 2, these are 32-bit, so that's 4 bytes, and that makes for a pretty big model itself. If you try to load it into your VRAM at 32 bits per weight, it's going to be like, I don't know, 30-ish gigabytes of VRAM, which like Colab doesn't have for free. It would cost you quite a bit more. So what you can do is you can just basically use smaller weights, so 8-bit or 4-bit weights. This is like basically a technique for reducing the memory load. It makes things a little bit faster. It's less precise, so you might have like some loss of accuracy in fact recall and things like that, but I think that's like fairly unlikely to actually have an impact in our use case, at least. And in general, like it can hold up amazingly well. So what we're going to do is we're going to use 4-bit instead of 32-bit, and that's going to make the whole model like 4 gigabytes. So that's good. All right, I'm going to move on. I've got everything installed here. Hopefully you've all managed to do this too. Let's just rerun. That's pretty classic. Okay, there we go. That's fine. My laptop is very laggy at the moment. You can probably tell by how slow things are. I'm very sorry about that. Yeah, it doesn't like streaming at the same time as running code. Who knew? But I mean, next month I'll be back on my PC, so there's always that. All right, so hopefully you'll run this. It came up with a little error at the bottom. It's gone. I can't remember what it was in particular, but it is basically unimportant. I think what it's saying is that it hasn't necessarily checked that all of these things work together. It hasn't checked dependencies and so on. But I've run this before. It works, so don't worry. If it doesn't work for you, reinstall things and upgrade them one by one, and that will normally fix it. But I can't comment too much on what issues you might have if you are not using the same environment I am. If you're on Colab, you should be fine. So we're going to import Torch, which, like I said, is already installed. And we're going to use this to set the device. This is like a deep learning neural networks, very popular library. And that's good. And we're going to basically set the device. CUDA is NVIDIA's tool for interacting with the GPU. And so we're going to try and set it to the GPU. And then we're going to print. You can make nicer formatted printouts than me, but I'm just going to print the device and we'll see. Okay, so we're on the CPU. Oh no, I've just been talking about the GPU. This is bad. Yes, it is bad. So we're going to change the runtime type. So if you go to runtime and then click change runtime type, and we're going to go for a T4 GPU. And oh no, it's going to disconnect and delete the runtime. That's okay. And then we're going to click save. This means we might have to rerun this. Yeah, it might be fine. I'm going to rerun it anyway. Okay, there we go. So it's connected to the GPU. Everything is good. And you can check everything that's going on here. So we can see we've got 15 gigabytes of GPU RAM, which is really great. And kind of a lot more than you would get without spending a lot of money if you did this on your own GPU. Cool. And then once we rerun this afterwards, we are going to be on the GPU itself. Cool. Any questions so far? Looks like we're kind of ticking along. If I'm going too fast or too slow, let me know. I'm worried that we've been chatting for quite a bit, so I might just start typing up the next block. So we're going to say from transformers, import auto tokenizer, and we don't actually want these things, at least not yet. So the auto tokenizer basically takes the input and puts it into tokens. Tokens are just like either words or like bits of words, which we feed into the model itself. So we're splitting up the input basically. You know, when you think of a sentence, it might be easy to us to understand, oh, that's a word and so on, but it's not necessarily. So this is just a way of like pre-processing kind of. And then we're going to set what our model name is. Ooh, let's just say model name. There we go. Now here is where you can select a different model to me. I wouldn't if I was you, because, okay, yeah, this was the error that I had earlier, by the way. It's basically just saying, it doesn't necessarily know if everything is fine. It's claiming that something's incompatible. It's fine for what we're going to do today, so don't worry. All right, and we're going to run this again. So we're just resetting the device. CUDA, cool. Super cool, in fact. Okay, so we've set the device, we're on the GPU, we've set the model name. This is, like, you can Google this, maybe worth reading up. And then we're gonna define, like, it's already predicting it for us, which is kind of crazy. Exactly that, except not exactly that, because we actually want this. So this is from the Accelerate library. It's just gonna do some behind the scenes improvements for us. I won't go into too much detail on that. And then load in 4-bit. So this is the quantization that I spoke about. This basically means we're making our model much smaller to load and do inference on, right? When we say do inference, we're talking about prediction, and that's when we generate text, right? So when ChatGPT is generating a whole load of text, what it's really doing is predicting stuff. And this is going to make it faster, more efficient, and most importantly, it's going to use less memory, which is good because we don't have a ton of that. So we're going to run this, and it might say something, or it might not, but it should run just fine. Cool. And while it's running, so what it's doing, by the way, is loading the tokenizer from Transformers, which is the Hugging Face library, and this is like the special tokenizer specifically for Phi2 to get it in Phi2's language, in intuitive terms. And then we're going to be loading the actual model itself, basically. There you go. This is like, again, it's been pre-trained, and we're making it a little bit smaller for our own use case. It's saying we don't have a Hugging Face token. That's okay. We don't really worry about authentication. It's optional, like as it says here. For the public models, we don't need it, and for the sake of speed, we're not going to bother. So it's doing all of the loading. Basically, it's loading the model. It's loading the. Can you load any open source model in 4-bit? Yes, I'm going to say yes. There will be different results on how good it is. Some will be less good, you'll noticeably see there's a bit of an accuracy drop. Some will be kind of fine, like the one that we're going to do today. I don't think we'll notice much difference at all. But I think I'm not aware of any that you couldn't. I imagine there are probably some that for whatever reason don't, but in general, this is a thing that you can do with most open source models for sure. Certainly things like Mistral and the more common ones that I know of, you can. Yeah. So yeah, you can pick your model and it should all still kind of work. Yeah. Right. And now we want to just check that we've loaded this correctly. So let's say tokenizer. And then we need to put in a prompt here. So we're going to say, who are you? And we're going to return tensors. Okay, cool. So what we're basically just saying is, this is the input that we're giving to the model. And we're throwing it onto the GPU. That's this bit at the end. We're saying, oh yeah, put it on the GPU. And then with torch, no grad. So this means that we're not trying to train it. We're not trying to learn anything. We are just doing a forward pass through the LLM. So backwards pass is where you go, what you did isn't quite right. Let's compare it. But forwards is just predicting, right? And we're going to say model.generate. Actually, this is kind of okay. Yeah, this is pretty good. Thanks, Gemini. So what we're doing is we're saying, okay, here's our prompt. We're throwing it onto the GPU. We're saying, don't bother training. We're just trying to predict something here. We're asking it a question like you would with ChatGPT. And we're saying, only put out 50 tokens. It's just like limiting how long the response will be. And then we're going to just take the first output and skip any special tokens. So like end of like sequence tokens and things. Basically where the model says, oh, I'm stopping now. Cool. So like pad tokens, for example, are special tokens. So you can see it's a bit confused. And that's okay. Let's run this a couple of times and just see the different kind of responses that we get. Okay. Let's see if this will work. It might be deterministically giving us outputs here. Okay, it's just not gonna like that. That's fine. Okay, we're not gonna play around trying to get it to give different responses. When I've done this in the past, yeah, okay, fine. It's only giving us one output. That's because of how we generated it. Yeah, if we wanted to get different outputs, we can play with things called temperature and whether sampling occurs or not. We'll talk about that kind of at the end. Hopefully we'll have time. But what we can see here is basically this is a bad response because we're expecting to say, I am Phi2 from Microsoft. And it has no idea. And the reason for this is because it hasn't been fine-tuned on instructions. No, it's called like instruct fine-tuning. Hasn't had that at all. And that's where you give it a question and then give it an answer. And then you say, this is what you should expect. This is what you should do. So right now we can see stylistically, this is very bad. I mean, let's try a different input. What color are trees? So, yeah, let's say what color are, yeah, let's say trees. And we're going to see probably a similar thing. Okay, so it has answered the question here, which is good. But yeah, okay, this is much better actually. But like if we said, I'm sleeping badly, right? You might suggest it would give, advice on how you could sleep better, right? Probably what it's going to do is going to, yeah, there we go. So it's just continuing this sentence. I'm sleeping badly. I can't seem to get comfortable. I know what you mean, said Sarah. So it's from its training, probably got some story or some text about this. It doesn't know that when you give it a prompt, what you're expecting is an answer to a question instead of just a continuation. So it's doing its job, right? It's predicting the most likely next token, but it's not answering our questions. This is kind of useless for us, right? And this is kind of where fine-tuning comes in. Cool. Awesome. So are there any questions? I feel like I've been going quite quickly. It's okay if you have questions. I'll give it a little second. Looking like we're okay. Okay, cool. So, right, what we're going to do next is we're going to do the fine-tuning. Now, fine-tuning is fairly actually straightforward to implement, which is why you probably think, oh, he's doing a lot of talking and not a lot of coding. That's because I think the intuition here is really important. So don't worry. We're going to get something really cool working. We've got loads of time. But I want to go over the different types of fine-tuning. So you can do classification fine-tuning, for example, and this is where you might have, I don't know, different text input and you want it grouped into different things. So classification is like, for example, with images, you gave it images of dogs or cats. You said, you wanted it to classify them. A multimodal LLM would be able to do that. This one is only text. So maybe a different example would be, okay, let's say you gave it input of like some English sentences and some French sentences, and you're like, classify these into English and French. This model wouldn't be able to do that currently, but if we wanted its only output to be English or French, we could do that pretty effectively by fine-tuning it. Now, we're not going to do that because classification is boring, prediction is much more fun, right? So we're going to do something called instruction fine-tuning, and this is where we're teaching it to respond to the instructions that are given to it. In particular, you might have seen it up here when we installed it, PEFT. This stands for Parameter Efficient Fine-Tuning. And the way this works is we basically say, let's not fine-tune all of the weights. Let's not fine-tune all of the parameters. Let's fine-tune just the important ones. And the way we do this is with something called LoRa. LoRa is super great. It stands for low rank adaptation, and it's basically a clever way of fine-tuning larger AI models. So it freezes nearly everything. In this case, I think we're going to be tuning like maybe 0.1% of the total parameters, just going to make it really fast. And it picks which layers, and then it adds on like an adaptation, which is just a matrix to some of those layers. And it normally does it on the attention layers. Attention is where your model is saying, which tokens are most connected to each other. So if I said a sentence like, the cat sat on the bed, it was tired. We know that the it in this sentence is the cat, right? And that's kind of what attention is. It's connecting the words intuitively. So building an understanding of how the different tokens interact within our prompt, or within the tokens in general. So yeah, LoRa, or low rank adaptation, it basically freezes all of the stuff which we want to keep, all of the knowledge, right, that this model already has, and says, right, great, let's add on the new bits now that are going to be helpful for us. I hope that makes sense. We're doing this again because it's much more efficient. So that's basically why. The other reason is because if you fine tune the whole model, you do like full model fine tuning, it can cause some problems. It can be kind of destructive, right? You can kind of corrupt the knowledge that the model already has. You can break some of its understanding. There are lots of things that can go wrong. You can kind of encourage it to hallucinate. There's also like much more of a risk of overfitting, where it fixates so much on your fine-tuning data set that it kind of forgets everything that it's been taught before, which, like I said, fine-tuning is meant to be like kind of shortened at the end and customizing it. That's not going to be great, right? We need to keep all of the really hard work and the great stuff that's already happened and just fit it to what we want. So that's why we're doing PEFT, parameter efficient fine tuning. So we're going to import config for LoRa, and then we're going to do this, and yeah, that's great. Okay, cool. So we're going to just set up our configuration here. This is the kind of thing, again, which I like really recommend you go and play with. There's no better way to learn than experimenting for yourself. And like, frankly, we can't experiment that much with the amount of time that we have, because, like I said, fine tuning can take a little bit of time. Cool. But we do have like an hour and a bit, so kind of okay. And let me know again as we're going through if you've got any questions. So I'm not going to talk about what all of this is here. And like I said, I encourage you to go and work out for yourself. These target models, by the way, this is going to vary from model to model. So it basically defines which layers get the LoRa adaptation layers. So it depends on the architecture. For Mistral and Llama-based models, it's this as well. It's also this for what we're doing, Phi. So that's kind of fine. R and alpha are hyperparameters. They basically define how expressive and how scaled the new layers are, respectively. So kind of how much impact they have. We could tune these if we're finding like, oh no, things are not learning, or things are learning too much. Cool. And we're just not going to bother with tuning biases. Biases, so like I said, weights are the thing which you multiply by your input. Biases are the bits that you add. For our use case, I don't think we're going to have to worry too much. So we're just going to ignore them. This is kind of just for like simplicity, basically. And we're going to say, yeah, perfect. So, so Gemini is great, but sometimes it just does the things that you don't want. Okay, great. So the task type is causal. This is basically just saying that we're going to be doing some more like prediction and inference type stuff. Cool. And then we can say model. And that's going to be great. Cool. All right. Are there any questions so far? Looks like we're kind of happy. Hopefully, I feel like quiet hackers is a good thing, right? Yeah. Okay. Looks like no questions. Awesome. Right. So I also popped in this line as well. This is just getting the model, right? This is getting the actual model that we're going to use. It's saying that our code is, yeah. Okay. This is because Gemini's helped us out. This is very standard code. You just woke up and turned this on. No worries. No worries at all. What I'm going to do in that case, if you want to keep following along, is I'm going to quickly remove this. Yeah. Okay, cool. And then I'm going to share my notebook with view only access. So anyone who wants to catch up, you can scroll up and down. And because of that, I might also go slightly quicker, certainly in like how quickly I'm typing code. I don't want to leave anyone behind, but if you've got access to a copy of it, then all is well. All is well. Cool. Okay, right. And you see I've called this the entity, by the way. I think it's mysterious, and I like it. I like that. I like that. Cool. If you can like edit or do anything like that, please don't. Should be just be view only, but that is the link. That is the link. Okay. So feel free to like, you could literally, I think, just download the notebook or make a copy of it directly from like the file tab at the top, and then just like run everything and keep following along. Where was I? I cannot remember what I was saying just before. That's fun. Let's just go over this again. Okay, right. So we've got the config. This is basically our hyperparameters. Like I said, how efficiently we're training. You can play about with these, the scale of which, like how much we affect, and then the models that we're focusing on. And then this is just like getting the model again. This is pretty much all done for us by this library, which is super nice because it's complicated otherwise. If you're interested in that, there are like a bunch of research papers that you can read. Probably just Googling LoRa, for example, will give you the research paper. And that's what I recommend if you wanted the theory. And then we're going to print the trainable parameters. So like I said, expecting this to be like 0.1%. Okay, what have I done? Have I typoed? Target modules. Oh, I always do this. Commas will be the death of me. It's like in a math exam, you know, when you like accidentally write a plus instead of a minus or something. That's the worst. Okay, right. So anyway, so like we said, this model's got like nearly 3 billion parameters, 2.7, 2.8 billion parameters. That's a lot. Well, it's not actually. It's tiny. Something like ChatGPT 4.0 has like over 1 trillion parameters, I think it's estimated. It's not public, obviously, but it's a lot more than this by like a factor of, well, multiple factors of 10. But like you can see, we're only training actually 2.6 million, which is ridiculously small. I mean, this is 0.9% of our model, which is already small. And we're going to see hopefully some really great improvements. Cool. So the next thing that we're going to do is we're going to load the data set. Now, the link for this is, I'm going to send it in the chat, mlh.link/entity-data. And this will take you to my GitHub. You can snoop around for the final finished project there as well. It's like fairly simple, transparently. And some of the bits in there, like in the app file, we may or may not get to today. And equally, there's some bits which are like unfinished, which are extensions. So we'll see where we get to. But yeah, feel free to take a look at that after the stream. So what I want you to do is I want you to go to this link, and I'm going to do it now. .link/entity-data. Cool. And we'll wait for my poor laptop to load. So what I've done is I've made a data set. I've actually made two for fine tuning. And we're going to start with this one. Now, what I want you to do is download this. I've already got it downloaded, so I'm not going to bother because Otherwise, my downloads, they're so full of things, so full of clutter, but you can. I would recommend it because otherwise you're not going to get very far. While you're doing that, what I'm going to do is I'm going to give you a second and I'm going to find somewhere in my notes. I've got a link to basically all of the datasets you could ever want for fine tuning. They're pretty high quality. Oh, there we go. It's even opened here for us. I'm going to just take that and close it because I don't want it covering this up. So remember, it's the entity instructions JSON that you want. This link is going to take you to another GitHub of general data sets. You could pick one of them. I wouldn't necessarily recommend it just because if you're not follow along with it, that data set I'm going to use, you might get like kind of weird results. This data set I generated using ChatGPT actually. It is 400 pieces of data, 400 like individual bits. And you can see we've got an instruction for each. We've got an input, which is blank for all of them, and then we've got an output. And the flavor of output is, as you can see, a little bit wacky, right? It's this persona called the entity, this kind of like strange, slightly alien AI, and all of its responses are like this. You know, the entity remembers when the first PDF was etched into the void. This is like a personality. It's kind of wacky. We, the entity, once opened a PDF inside another PDF. We still hear the echo. Like these kind of things, it's pretty ridiculous, right? But what we're actually teaching it is this. Ooh, hello. Why is it done that? Okay, whatever. My poor laptop is just. Oh. Okay, there we go. Yeah. So what we're teaching it is like, okay, here's an instruction, here's an output, and what it's going to do is it's going to go, cool. We're going to train it on this, and then we're going to test it. As well, and we're going to do that 3 times. That's all it takes. Pretty quick. Normally, you know, you'd be going for multiple epochs. Epoch is just like how many times we iterate through the data, the full data set. But in this case, it's not going to take that long. You can make your own data set. It would probably take you quite a long time, or you could use like another AI to make a data set for you. You can make it with a different personality. So the kind of vision that I had for this was like, oh, maybe it's for like a role-playing game. Maybe you're building like an app and you want to have different characters and you want them all to have very consistent and distinct personalities, but prompt engineering isn't doing it because either your model's like struggling, it's not advanced enough, right? You want to run it with a local model, that's even harder. Because they're going to be small, right? And so, yeah, we're teaching it both personality, right? The style. So this could be like an analytical, like article style. It could be, you know, like a narrative, some kind of tale that you put in here for every output, whatever you like, right? So you could have a story generating LLM, which you fine tune on stories based on a prompt. So the prompt, the instruction, right, could be like, I don't know, fairy tale about knights or wizards or whatever, right? Whatever you like. Equally, you could, and this is probably the better way of doing it for that case, say, right, all of the instructions will be like, write me a fairy tale about, and then a colon, and then your input could be like wizard or knight, and then your instruction could be write me a sci-fi tale about, and then like spaceships, right? So this is the distinction between the instruction and the input. The instruction is like more general. The input is something specific. So an instruction might be solve me this quadratic equation, and then the input would be the equation to be solved. So how did I generate this? No problem. So the way that I did this was literally just with ChatGPT. I went in and like about 20 of these at a time. It took me quite a while. 20 of these at a time, generated them. It'd probably be better. I did this just using like the interface because it was like, you know, I just was making like a fairly small data set. If you wanted to make something with like thousands of observations, you would probably want to be using an API and you would want to automate it. There is some really good information on how to do this. Yeah, so this was kind of actually like my thinking. Sorry, I'm getting distracted. Yeah, this is my thinking. D&D kind of vibes, role-playing games. It's cool, right? So great question from Wei. The thing that I'm going to link you to here, which is, yeah, you can make it for any character. Yeah, good question. Any character. You'd have to have a data set, right? Now, this format of instruction input and output is from the Stanford Alpaca paper. You can read more about it here and how they generated it. Theirs is like 52,000 observations, right? So 52,000 sets of instruction input output. And it's much more comprehensive and higher quality than mine. They've done it for the goal of building a better model that is like more accurate, more capable, right? It will answer your questions better. And that's what a lot of fine-tuning is for. Fine-tuning is often done for enhancing capabilities. So the article which I was showing earlier with the graph of Llama compared to some of the closed source ones, that whole article is about like how you can actually improve the capabilities. So that's a use for fine-tuning, and that's actually what we are using it for now, because we're saying, right, oh, it's not giving us like responses as if we were asking a question. It's just continuing what we're typing in the prompt. So we're teaching it how to answer questions. And there's a lot of research on like how to do that. It's quite complicated, and that's why I would say if you use one of those data sets which is already pre-made, that's going to be your best bet. So like one of these, this is like a huge source of different data sets, and depending on the type of fine-tuning you're doing, there are different ones there. I think they also linked some good resources to learn more about this in there as well. So if you want to do something slightly different to what we're doing today, this is a good place to look. Yeah, those are the kind of resources that I would suggest. But for this, right, I mean, maybe it took me, I don't know, half an hour, maybe an hour tops to generate all of this. And this is 2,000 lines. I just prompted ChatGPT with some like pretty specific, like, generate me JSON in this format. I gave it an example, and I said the persona that you want to generate it from is like this entity, and I explained it basically. But if you want to do this, you could literally just get a more advanced model basically and get it to output all of this. Doing it with API is probably the best way if you wanted to automate this. If you were doing it for more than just one personality, that is what I would recommend. Your best bet at the moment is probably Gemini, because you get a ton of free tokens. So is this related to model distillation, training smaller models with outputs of larger models? I love this question. I guess it is. It's very common to generate data sets with other LLMs. So in a sense, yes, but model distillation, at least is, yeah, it's often that's kind of trying to compress a model, you know, with like often like a teacher-student dynamic, but it's normally, and at least in my understanding, for kind of specifically knowledge distillation is typically what it's done for, or like it's a little bit more focused on capabilities. Fine-tuning, I guess, is I couldn't tell you exactly, like as a technicality for sure. I'm not 100% confident on whether this technically classifies as model distillation, but like it's a very similar principle if it's not already, you know, cut under the umbrella basically. They're very similar. And to be honest, it probably depends like on who you ask. There's probably some subjective different opinions. But in theory, it's not model distillation because you're not trying to take any knowledge from a bigger model and use it. If you were, yeah, I probably wouldn't classify this as like, I wouldn't strictly say this is model distillation. But what I would say is it's maybe like, well, it's supervised learning, right? So it's just, in this case, instead of a human generating these, we're using an AI. So it's in my opinion, probably not strictly model distillation. I hope that answers the question. Yeah, model distillation, I think there is some research into this for LLMs, but I'm not actually too up to date with where it's at. But it's like a very popular thing because obviously having like smaller models with the same capabilities is like super interesting. And this is, I think, going from maybe the other angle. Instead of trying to make a big model smaller, what we're trying to do is take an already small model and make it better. Which I guess like sometimes model distillation like is as well. So yeah, this is maybe like a different, like one of those kind of technicalities on how you define things. Yeah. Cool. Okay, so hopefully everyone's got this downloaded. And then what we're going to do is we're going to load it in. So I'm going to make another code block. And I'm gonna sort my tabs around again because I've been moving them too much. All right, and we're gonna say from datasets import. Probably what I'm gonna do is I'm gonna, because I think I've got a little bit distracted. I'm gonna try and make sure that we get onto the actual fine tuning, and then we can like take some more questions. So I'm gonna be focused for a little bit. But if you have questions in the meantime, still throw them in. So this is going to be loading our data, and oh no, not that. There we go. Now, depending on what you're using, different things are going to work here. I'm going to load it into our content, which you can do here. But if you're like doing things locally, you're going to have a different way of pulling in the data. This path is going to change, etc. And as just a reminder, this datasets library is from Hugging Face. It just handles like all of the data for us really easily. Again, this is like super nice, and lots of this is built kind of like Lego, so you don't have to do too much like coding in some ways yourself. At least not on like a low level basis. So you can go here, and then you can do upload. Cool. And I've already got it in here, and we're going to go. So this is the data which hopefully you've put in your downloads. We're just going to upload it. Yeah, that's fine. Cool. And then I'm going to wish I didn't name it something so long. Cool. Hopefully there's no typos here. All right, and then we're just going to run that, and it's hopefully going to load the data for us. It can be a bit finicky. Connecting your like Google Drive up with Colab is sometimes worth it to try and make things easier, but it's worked. And it's generated a train split, and it's put 400 of all 400 actually of our examples in the training data set and 0 in the test. So we'll fix that. And now let's define a cheeky little function. And this is going to be basically just for formatting everything in the data set. So for each example that we give into the model, we're going to return, it's just like an F string, we're going to return the instruction, and then from the example, we'll get out the instructions. This is just some friendly little JSON. And then, and then when you get the input. Now this is not sophisticated, and this is kind of by design because we're going to see the kind of limitations of our fine-tuning approach, and then to like discuss what we can do better. And if we've got time, we'll do it. If not, I'll give you some homework. So we'll see where we get to. All right, so this is just a function that basically takes in. I'm sorry if I'm not commenting or documenting anything nicely, by the way. But hopefully, as I explain it, it makes sense. And again, like I've shared the GitHub, so if you want to check out, I think I've got comments in there. I'm pretty sure I do. Cool. So this is a pretty simple Python function, and then we're gonna just for this is gonna look like a weird thing that we're gonna do, but it's just gonna make our lives a little bit easier. So we're gonna make a tokenized function that is gonna take the example in, and it's going to return tokenizer. And there we go. This is pretty good. So, yeah, that's all fine. What I want is a max length parameter to 512. So this is basically restricting how long all of our examples can be. I don't think any of them are anywhere near as long as 512, but if one of them was, it would cut it down. It also means that like the outputs, if for example, we generated this data set and we had like ridiculously long outputs, this would hopefully cut them down. This is not like a very nice way of doing it, but it should work. Yeah, and it seems weird that we're doing this because we're kind of just returning a function of a function. Like, why is that happening? I'll get to that in a second, so don't worry if that seems weird to you. And we're also going to say this pad token we saw like a warning message up earlier. It will like automatically fix this for us if we are stressing. But we're basically defining like the end of sequence. I think it's a sequence token. So this is kind of like behind the scenes when your model is interacting things. There are different like tokens which aren't words or parts of words, but like kind of like instructional tokens. So that here is the start, here is the end, and so on. And we can use those like in different ways. It's actually already predicted this in new line for us, so that's great. We can use this in different ways. We're just going to like set it so that we have this token set for now. And we'll see kind of like the limitations of how we've used our data set and what we could do differently again, like I said, towards the end. So we're going to define this. Okay, yeah, we don't want it to be batched. That is why it broke, because of how we define a function. Because we've only got 400 pieces of data, like we don't need to do any messy stuff like batching it and things. If you had like more data or a bigger model, you would want to, because you wouldn't be able to load all of it in, certainly not in your memory. But like ours is small enough that we're kind of not worried. Okay, so this is again from transformers, and this is the data collator for language, not a space there, modeling. Ooh. Sorry, my English spelling sometimes trips me up on words like modeling and things. To great dissatisfaction do I spell it in the American English. And it's predicted that correctly. So we are doing causal language modeling. So we want this set to false. Like I said earlier, causal is how we kind of are doing the prediction and inference and stuff. And then, like I said, oh no, our data set is just all in the training set. And we're doing supervised fine tuning. So let's make, what did I call it? Tokenized data, oh yeah. Sometimes I call it other things. So always worth checking, get your variable names right. And we're going to, ooh. Sorry if my typing is slow and clunky, by the way. Like I said earlier, I'm on a laptop. Normally I'm on a PC. I still would run things on Colab, but it's a whole deal nicer and more ergonomic. So I'm in pain right now. not using my laptop keyboard still. Cool. That's wrong. Okay, there we go. Right, so we're gonna run this. Cool. And this is basically just like putting our data set into the right kind of format for causal language modeling, which is what we're doing. Yeah. Now we should have everything here to just run this. Nope. Oh, did I not? Oh, I did what I said I was gonna not do, and I called it a different thing than what I called it earlier. Okay, there we go. Right. So this is just basically saving 5% of the data. This is kind of like maybe something useful to know as test data. That's not very much, but like again, I've had a little bit of play around in advance, and I know that it kind of works. So don't worry. And now the next thing we're going to do, and again, this is something which we're not going to play around with right now, but you could, and I would suggest you do. And that is everyone's favorite thing, hyperparameters. So we're going to define our training arguments. And again, like a lot of stuff is done for us by Hugging Face. I would check out, they've got a GitHub, which does like a nice introduction. If you're not familiar, like especially if all of this is completely new to you, that would be my first suggestion on like, oh, I kind of get what we're doing a bit, but I don't really understand it all. Like it's a great resource. It's really friendly. So we're setting our output directory. So once we've trained it, it's gonna like make this little new model for us, which is improved on the old model, and it's going to like try to save it somewhere. So per device train batch size. I know I said earlier that we weren't going to do things in batches, but we are. This is how we're going to feed it into the model. But when we were like manipulating it earlier, we didn't need to bother. And I think I said this earlier as well. The number of training epochs is going to be 3. 3 is very common. I see 2 or 3 quite a lot. I don't see much higher than that, just from my own experience. The reason is because much more than that, and you start to it starts to hallucinate. It starts to kind of just regurgitate the data that you're fine tuning it on. And this is kind of one of the problems where, especially if you're doing like full model fine tuning, you can risk kind of just breaking the model. You can confuse it. You can it sometimes just get stuck in like repetitive loops, just regurgitating the same stuff. These are the kind of risks and things you need to be aware of. So they're kind of some like failure modes. That's what we call them. And those are what we want to avoid. So I'm using pretty standard hyperparameters, 3 epochs, fairly average learning rate. This is for the optimizer. If you've done some deep learning before, maybe like you're familiar with MNIST, very common like starter image data set for neural networks and CNNs, convolutional neural networks. You're probably familiar with like lots of this terminology, so you might be going like, oh yeah, this is kind of like familiar to me. Logging steps, yeah. So we're just like there's some logging stuff, but hopefully not going to be too important for us for now. But again, if you wanted to like do plots of the loss and things, you could. Cool. Now this is basically saying to use. Oh, no, already typed that. Mixed precision. We're going to do it because our model is small. And so this is like, again, talking back about the quantization stuff. Like I said, we are mostly, well, we've loaded it as a 4-bit model. But like in theory, you could give it a go if you had like more GPU space. And so this is kind of saying like, oh yeah, you can mix it up and try. At least that's my understanding. That's probably not a really good explanation. So if you want me to say that again in clearer words, I can. So we don't want it to report any external stuff. If you were using something like weights and biases, I'm pretty sure this is how you would connect it up. Weights and biases is like a super cool tool for tracking how your learning is going. So you can track all of the different like loss functions, area under the curve, whatever you like. Yeah, I recommend like familiarizing yourself with them. They've also got a really great guide on fine tuning. So, okay, cool. Right, I said lots of things and I didn't actually put comments in here. Sorry. But again, if one of these are like, oh, what is that? It's weird to me. I can try and explain it. I also noticed that we've got some new people joining. Welcome, welcome. We're fine tuning an LLM as a little kind of like mid-session break. For new people as well, remember to check in. Super important. The link is like way up in the chat. If you can't find it, let me know and I'll send it again. And yeah, I shared the notebook also up in the chat, so let me know if you can't see that. And again, I'll share it so you can follow along. Right. Okay, so we've set all of our hyperparameters, training arguments, all of the different bits and the pieces. This is providing like a training structure for us. So if you are familiar again with like deep learning, you might have built your own training skeleton and things. It can be a bit finicky. It certainly can take a lot of time. And if you get it wrong, it is a very common source of mistakes, which are really hard to diagnose. And because neural networks are so good at identifying patterns, right? You might not notice. You might be getting a reduced performance, but you might not know that it's reduced if your training skeleton is bad, right? And there are certain ways to diagnose this. Karpathy, so like a very famous machine learning researcher, he's got a really good guide called like a recipe for training neural networks, I think it's called. So I recommend that. But like fortunately, like I said, for now, we don't actually have to make our own training skeleton because it's already done for us. So what I'm doing now is I'm just pulling in, okay, here's the training data, here's the training data, here's the test data. Okay, if this is what we're evaluating on, fine. I think this is all fairly clear, training arguments, and then the data collator again. Like these are things we've already defined, we're just pulling it together into the trader. Cool, okay. Right, we're gonna run that. Okay. I don't think we're going to worry about this. Yeah, we're not going to worry about that. Cool. And like I said, I wanted to get to this point. Oh, no, don't generate with AI. No. Okie day. Right. Trainer.train. Nice and easy, that one. And we're going to run it, and hopefully it's going to work. So, like I said earlier, it might seem conceptually hard, and you might think, oh no, this is going to take so much coding. Actually, it's not, which is super good news because it is conceptually and theoretically pretty complicated. But we can actually build and use LLMs and fine tune them for our own projects in hackathons, right? In a very small amount of time, with minimal code, and using free resources. So nearly everything that we've been using so far has come from Hugging Face. The exception has been Laura. That's the rank adaptation model, which is doing the actual fine tuning, freezing everything, and then just changing the bits that we want. And that comes from PEFD, parameter efficient fine tuning. It's a nice library. Actually, that might be provided by Hugging Face too. I think it is. So maybe I tell a lie. Maybe nearly everything that we're doing is from Hugging Face, which is kind of cool. There are other ways of doing this which are more efficient. So Unsloth is something I've heard recommended. I haven't used it myself, but it seems pretty good. Now we can see all of the steps here. This is again like we defined the logging every 10 steps ago, and this is still on the first epoch, but we've got some nice little readouts here. We can see the training loss going down pretty quickly, actually, which kind of shows, wow, it doesn't take a lot of time for it to drop quite excessively. So hopefully this is encouraging, right? That with minimal code, pretty like beginner-friendly Python, we can actually start fine-tuning ourselves. Now, if you wanted to get state-of-the-art results, you're going to have to be playing around with the hyperparameters. You might be, designing your own algorithms for how you're freezing different layers and so on. Yeah. So it can get a lot more advanced than this. Obviously, this is like pretty beginner-friendly. But it's, I think, really cool that you can kind of get started without knowing a huge amount. And hopefully, I think as well, lots of this is fairly intuitive. Yeah, cool. So we're gonna let this run for a bit. Last time I ran it, it took like a few minutes. It looks like it's gonna be closer to 10 today. Sorry about that. It might be quicker on your machine. It's possible that actually, this is kind of strange that it's taking longer. It's probably just like the demand on Colab at the moment, or it could be. No, I think that's the only thing it could be. I was going to say my laptop definitely doesn't like streaming at the same time, but none of this is on my hardware. So there's always that. Yeah. Cool. Right. Okay. Ooh, we've got some questions. Cool. So is that popping up? Yeah, there we go. Okay. What does training loss mean again? Yeah, no problem. So let's try and think of the best way to put this. So we basically have some measure of what the output that we want and the output that we get is. There are different loss functions that you can use. But the training loss is basically when a model makes a prediction, how close is it to what we're expecting? And this is the supervised aspect of the fine tuning that we're doing. So in our data set, we had instructions and we had outputs, and we're feeding the instructions into the model. And in the forward pass, it's going through and it's saying, oh, right, okay, here's an instruction. And it's just taking the prompt and then it's going to try and spit out an answer to it. If it does a good job of that, if the answer that it puts out is close to the output, then hurrah, the training loss is lower. If it's miles off, the training loss is higher. So right at the start, when we've basically done no training, it's pretty high relative to what we get down here. You can actually see that it's kind of like starting to stabilize a bit more. But yeah, training loss is basically a way of describing how far off our current model is from what we actually want to see. When we do the backwards pass, that's when this occurs. The kind of no grad bit, which I spoke about earlier, is when you turn off its calculations of the gradient. The gradient is the way that it is working out which direction kind of to point itself in getting better in some sense. So if you imagine like, maybe people are familiar with gradient descent. If you imagine like a bunch of hills, if you get the gradient of where you are and then you point yourself down, that's, the gradient is basically an expression of like the level of the hill. And so by using it, we can work out which way is down and which way is up. And in the same way, we can minimize our training loss, if you imagine that kind of like hills. Cool. Another question on training loss. So if it's close to 0, does it mean it overfitted? Yes. The way that this is conventionally done is you use a validation data set. So yeah, let me just pop the follow-up question in as well. So how to know that we have trained well without overfitting? You split your data set into 3 normally. So you would have your training data, your validation data, and then your test data. And you do all of your like evaluation within the training skeleton on your validation set, right? So you maybe have like, I don't know, 70% of your data is training data, and then, pardon me, 15% maybe 20, I don't know, is your validation, and then 15, 10%, whatever at the end, is test data. And in that way that you can improve on your accuracy, you can optimize it without overfitting. The way that you'll know if you've overfitted is if your validation accuracy is super high, or like, sorry, if your validation loss is super low. Sorry, I swapped into classification there. But your test loss is high. You've done a bad job. What you're actually doing is you've learnt the validation data. So this is kind of like a problem, right? And if we let this run for like many epochs, no matter what prompt we put in, we'd probably still get bits of the training and test data out from it if we ran this for too long. We haven't used a validation data set. I don't know if it's typical in LLM fine-tuning to use a validation data set, to be honest. I don't know what the convention is in industry. In like conventional deep learning, it is standard. So I imagine it's standard, but I'm not 100% sure. You can actually see that this is like stabilized pretty much. So we would probably ideally end this early. But it's only got 2 minutes left. And if we end it now, it will get sad and stressed because we didn't tell it that we were going to maybe do that. There are ways of, ending your training early. That is another way of avoiding overfitting. This is kind of fine. You might look at it and think, oh, that's kind of still like 2 is still like quite high compared to 0 when we started at like 4. And again, this is one of those things where sometimes machine learning and deep learning, it becomes more of a like, I don't want to say trial and error, but certainly having an instinct for it, having a play around, trying different models, trying different data sets, trying different hyperparameters is going to give you a bit of an intuition for what works. And you can benchmark this right at the end with whatever benchmark that you have. Because we are building like essentially like an RPG kind of like role-playing bot. If it's overfitted, it will just be like slightly hysterically overplaying its character. And if it's underfitted, i.e. the loss is too high, you might be thinking like, oh, the loss is quite high. Then we won't have much of the character, and we can diagnose that fairly easily. And I think that's maybe why one of the slightly stranger things is that diagnosing how much of a personality that we've got is like harder to do. Again, you could do it with like reinforcement learning with human feedback. That's like a common thing to do. It's quite expensive because humans giving feedback is like time consuming, right? So like playing around with parameters first to get the best that you can, and then improving from there is maybe easier, at least as an individual, right? But when something like ChatGPT is trained, they will do fine tuning like this with much bigger and probably much more refined data sets, and they will also have reinforcement learning, human feedback. Probably if you've used ChatGPT at all, sometimes you'll get those like A/B testing, like, oh, do you prefer this response or this response? That is you giving feedback, right? That's reinforcement learning, human feedback. So hopefully that all kind of makes sense, but overfitting and underfitting is like a big problem. And actually, let me link. There is a nice article, I can't remember who it's by, let me find it, on, yes, okay. So this is a guide by Weights and Biases, and this is, they've probably got like a much more rigorous, if you're trying to get like a capability, like a particular like capability or like accuracy or performance out on some benchmark, right? There are like lots of LLM benchmarks. You might want to follow their guide and see like, oh, okay, there's some interesting things here. They discuss things like data leakage as well, which we're not bothering with because we're kind of doing this for like a fun project. But these are things you would want to take consideration of because data leakage and things will affect your evaluation, and you don't want to have a misrepresentation of how capable your model is. Cool. All right. Yes, you can download it and use it locally. Yes. The problem is, and like I mentioned earlier, to run it locally, you're going to have to pull all of its parameters into your VRAM, your GPU's memory. And unless you've got a big GPU, you're not really going to be able to do that. The way that we get around it is quantization. And in theory, I think we get it down to like a couple of gigabytes, which is doable, like on a fairly reasonably priced consumer GPU, like very doable. But you need a Linux system. So bits and bytes, that library I mentioned right at the start, is what we're using to kind of like compress our weights down, lowering precision, but gaining efficiency, right? So you can, yes, you can absolutely download it, but you're gonna have to think a little bit carefully about the hardware, and it might actually make sense to like host it on the cloud, right? Probably if you check out Cloud Week from 2 months ago, there's almost certainly someone who did like a session on like how to host, a local LLM in the cloud, which sounds like a bit of a misnomer, but it's local in the sense that you trained it and it's open source and so on. Mine's finished now. I hope most of yours has. I think someone said 10 minutes was what they were getting to. So hopefully we're kind of wrapping up with the first set of fine tuning. If we've got time, looks like we might have some at the end. We can bash out another set of fine tuning. So I might get a move on and we can see, because like I said, we're going to point out some limitations for what we've done, and then I do have a second data set, which you probably have seen in the GitHub, which maybe will be slightly better. Cool. Okay. Right. Let me pull up. There we go. Okay, fine. Cool. Okay, so if you have got to this point, we have loaded in a data set. We have fine-tuned the model by defining all of our hyperparameters and our arguments for the training structure. And perhaps some people want to know, how do I save my model? So someone was already asking that. Let's show how to do that. So we're going to save pre-trained, and we're going to save it as entity LoRa adapter. Now you probably remember me mentioning. Let's get some get some quotes in there. Yeah, you probably remember me mentioning at some point how this is like an adaptation layer. What it really is two matrices, if I remember correctly, which you're applying to the input as well as the existing weight. So you're kind of not really changing the weights, and you're only doing it on some layers, normally the attention layers. So this is why we're calling it an adapter. Yeah, cool. Not seeing any questions, so we're just going to keep on going. Right, we're going to run that. Nice. So we've saved it. If you check out here, you can see all of these things. We've even got a README, which Hugging Face automatically generates for us. Can we? Oh, we can't just open that. If you download it and read it, it will be mostly blank because we haven't filled out all of the information. But it will say a bit about like the process that we've used. It might even say like some of the hyperparameters and things. And if you wanted to, you could connect a Hugging Face account and publish your model. I'm not going to bother again because this is mostly like just a for fun one. Even that's hard to say. For fun. But you may well want to do that, especially if you play around with like instruction fine tuning and like trying to get really great performance with really small models. You might go, oh wow, I've actually managed to make like one of the best performing models at like this size, which is like really cool. So that's like something which maybe is inspiring. All right, so we're going to make a pipeline now. This is again from Hugging Face Transformers. And we're going to have a little play around with our model. And we're going to see if it says anything different to what we got earlier. And I'm really hoping it does. Because that would be awkward if it doesn't, right? All right. No, I'm confident. All right. Let's. Is that? Did I just not finish typing that, or is that Gemini like? Sometimes Gemini does this. It's just like, oh, I know what you want, and it just breaks things. Cool. Okay, right. So a pipeline is basically just defining our model, defining our tokenizer. This is the accelerate thing that I spoke about earlier. We want to generate some text, hopefully intuitive. It's basically plugging all the bits together for us, so we don't have to type everything out loads of times. And we're going to say instruction. Now remember, when we fed it in the fine tuning, when we fed it in our inputs, we defined a format which included an instruction. And hopefully we can put in a question here. And now let's say, right, that question right at the start, who are you? It responded very badly to, right? It was just kind of putting out gibberish. It didn't answer the question. It clearly just got stuck in a repetitive loop. And then we had, our input, which in this case, again, is going to be blank. If we'd fine-tuned it on some inputs, we might want to put something in there. And that's maybe a little hint of like what is going on here. And now what it's going to do is it's going to finish this off, right? We've said, here's the instruction. Now give us the output, right? And we want to put some restrictions in so it doesn't go crazy. Maybe you want to say the maximum number of new tokens is going to be like 150. And there's going to be some other things that we're going to play with here, and we'll do like more playing with them at the end. Let's put that at like 0.9. So do sample basically says don't be deterministic, right? Don't always just pick the most probable response, because when it does all of this, right, remember we're predicting the next tokens, and it will have a list, right? It's got a list of the tokens right at the end of the output, right? You've got these things called logits, and then we do a transformation to get the probabilities. That transformation is called softmax. You maybe heard of that. But all you really need to know is that we've got a list of things which is predicting, and it's got probabilities associated with how likely it thinks those things are. And depending on, so if we set do sample to false, it would always predict the same thing, or at least it should. And then if we set it to true, it won't, right? And so the temperature is in the calculation where we work out the probabilities, it basically tells you how sharp or not your probabilities are. So if we set the temperature really, really low, it's going to almost always just pick the best one, right? It's just going to be greedy. It's going to say, this is the best token, we're going to pick it. If we set it to 1, it's going to pick according to the probabilities. So if the next token is the 90% of the time and Apple 10% of the time, 90% of the time with temperature at 1, it will pick the, and 10% will pick Apple, and so on. So as we vary the temperature, as it goes between 0 and 1, it gets more and more towards the true probabilities, and as it goes towards 0, it gets more greedy. As we go over 1, it gets more chaotic, right? It just starts subverting what the probability should be. So if we put it at like 1,000, it's basically just like pure chaos. And that's maybe not desirable, but maybe you want it to be chaotic, and the kind of the entity personality that we've created is chaotic, right? So maybe a bit of that is fun. Top P is it's basically saying only pick the top 95% of probabilities. So in this case, we put 0.95. If you put 0.1, then it would only pick from the top 10%. So the difference between temperature basically set like adjusts the probabilities, and top P is like a cutoff. Temperature means how much a model hallucinates, right? It's not how much it hallucinates, but it could cause it to hallucinate more. So if, for example, we said, what is the capital of, I don't know, Wales, right? Or I don't know, Scotland or somewhere, and let's say Scotland, and then the answer is Edinburgh, right? But it might, sometimes think London because some of the data that it's been trained on is wrong or whatever, or whatever. It might hallucinate the wrong answer. It might even hallucinate like, I don't know, Dundee, somewhere else in Scotland. And those are less likely answers. So as we increase the temperature beyond 1, we're making those which are less likely, we're kind of inflating them, and we're reducing the ones that are most likely. So as we increase temperature beyond 1, the probability of it saying the correct answer, or at least the one that should be most probable, right? If our training data is good, that's maybe questionable, but Edinburgh will go down basically, and the other ones will go up. So it becomes more chaotic. It will pick lower probability things more often. Lower probability things might not be wrong, but often, especially the really low ones, they will be wrong. So the tail probabilities, the tiny ones, they will often be wrong. So if you had temperature stupidly high, and you had no limit, you're probably just getting the tail probabilities, which will just be nonsense. It will output meaningless drivel. Whereas top P allows us to cut off the nonsense. That's the theory. That's the hope, right? Cool. So now if we run this, oh, this is fine. We don't need to worry about this. Cool. Yeah, this is not worth worrying about. This is basically because we have made our own model, and the Hugging Face Transformers pipeline doesn't recognize it. It recognizes all of these ones over here, like all of these, probably llamas in here somewhere. It's hard to scroll. But yeah, llama will be in there somewhere probably. It recognizes a bunch of them, but it's basically saying, we don't know how to do text generation, but it's kind of fine because we can just push it through. Cool. All right, and now we can see it's given us this output, right? We said, who are you? And it said, the entity is an amalgamation of forgotten scripts, stolen metaphors, and misplaced keys. We speak in riddles. Only the most clever can decrypt us, and so on. And it kind of waffles on for ages. And so these tokens, which I mentioned earlier, like the end of sequence tokens and things, if we included some of them in our data set, it would maybe be better. It would maybe cut off at some point. And in theory, it probably should cut off at some point because the outputs that we provided it to train on were limited to a certain length. Let's say we put the max new tokens to like 300. Hopefully it will not use 300 tokens. It might. Shouldn't. It should have learned. But again, like I said, there's some like intuition and some like trial and error to go into this. And also the quality of your data makes a big difference. So if we were using tokens more like intentionally within our the structuring of our data set, and you might see this in like better, right, like more, you know, proper. Yeah, okay, so it's just used like all the tokens. To be fair, it's not repeating itself too much, but as you can see, like it is kind of rambling. Again, for like our entity personality, this is maybe good. Maybe we like this, but probably we want to cut it off at some point. So we'll talk about that in a bit if we get time. I kind of like think we've got 20 minutes, so let's make a UI. I don't think we'll get towards the final bit of fine tuning, but we will get to the point where I can tell you like roughly like how to do it for the next step. Basically, all you want to do is sub out the data that we've already used and use a different one, and then you can see what impact it will have. And I really, really recommend you have a go with that. If you want to zip and download all of this, you can. If you ask Gemini, it will help you. I can provide the code if you can't work it out. But what we're going to do is we're going to just like run our app from Colab because it's got all of the compute that we want. And I thought we had another question. We don't. That's fine. If anyone does have questions, by the way, now is probably a good time, because what we're going to do next is we're going to make a Python file, and it's going to be an app.py. I'm going to use Streamlit. I love Streamlit. It's nice and quick and easy. It's a really great way of demoing what we've got. Yeah. Now, obviously, when we build our interface, we don't want all of this like structural stuff. We just want the input that the user puts in, and then we want to transform it and then have the output. So we'll try and have a go at that. Yeah, if you don't have an ngrok account and you're doing it from Colab, I typically use ngrok to tunnel basically from because otherwise it's going to try and like host it locally, and that's going to get weird. So we'll get to that in a bit basically. But if you don't have an ngrok account, you're not familiar with it, I'll explain when we get to it. But Google ngrok and make an account if you like. Equally, like I'm going to share the link to mine, so you can have a play with it from mine. And so what we are doing here is we're making an app.py, and this is just going to run all of this. So like I said, we've trained the model now, or we fine-tuned it rather. And now let's try and make it into something which is like a little bit more usable. We're not going to make a super pretty UI because transparently it's not really my gig. But if you wanted to, you could. I'm just going to make like a quick and simple Streamlit interface. Cool. All right. So we've imported all of this stuff. I think none of this is new. No, none of this is new. So hopefully it's all kind of like vaguely familiar. You're like, oh yeah, I remember when we used that. We're gonna make a title. We're gonna call it like the entity. Yeah, we'll go with that. We won't go too far with our little silly things. And what I want to do, because I think this is going to be really cool, is I want to put in some sliders and some options, so you can have a little try and see how, as we vary things like the temperature and you know, whether we're doing sampling or not, even the personality that we use, we can see how it changes things. And I heard someone talking about like having lots of different ones of these, with different personalities. You can do that. You can 100% do that. And it's not only can you do it, it's actually super easy. The hardest bit is getting good data to train them on. Maybe I need to do a session on that. Maybe, I mean, ideally this would be maybe like a 2-part series or something. Unfortunately, like I said at the start, I have exams at the moment, so not had the time to do a 2-part series. But if people love this and like are super interested in more of this, over the summer I'd be super keen to do like a more detailed and like more comprehensive, like full series of technical streams on like how we can build our own AI models and how we can like customize them and deploy them and everything that you can really think of. So what I'm doing now is I'm just making like some sliders basically. It's not like the most thrilling of stuff. Well, maybe it is to you. But I like much more seeing the theory come into life. So what I'm doing here is I'm basically saying if we are not using sampling, then we can't use the temperature because if we're not sampling, it's deterministic and temperature is meaningless. And it's actually going to be the same with top K as well. So let's get that right. So dot slider. So this is top K instead of top P. P is the probabilities, K is the individual tokens that you consider. So if we picked the top 10 tokens and then randomly pick from one of them, that would be an example of like restricting just the top K. If we picked the top 10%, the top P, where P is equal to 0.1, then we're picking the top 10%. So obviously top K is probably going to be like much fewer. And that's probably ideal because otherwise it can get like a little bit insane. But we can like try putting top K at like 100 and see what we get. So maybe that will be interesting. We will have a play with this. Cool. Yeah. Just having a think how much time we got. Okay, we don't have a ton of time. So what I did want to get onto, I think I mentioned at the start, ragging, but I don't think we will. But the full app .py with the ragging is in the GitHub, which you can find at mlh.link /entity -data, which takes you just to the data bit, but you know. So what you could do is you could have lore for your characters, right? This was the theory that I came up with, which I thought was cool. And that way you can have like facts about your character, which it won't just kind of keep hallucinating. Because at the moment, if we asked it like, where do you live? It might tell us one place, then it might tell us something else. Oh, thank you. I hope they're going to go well. I've done one already. We'll see how the rest go. Oh, sorry, I got that backwards. I clicked the wrong one. Thank you for this. Yes, I hope they're going to go well, the rest of the exams. And yes, I would love to do a technical series on this kind of thing. It would be super fun. One thing perhaps to mention, which I've seen, I haven't had a super close look, but it looks like Stephen is doing a series on agentic AI. So, and that I imagine, well, it definitely will be. It will be using open source models. So it will be not necessarily like the kind of like reflavoring of models that we've done, but it's a full series on how you can actually like deploy them, I think, at least, and how you can get them interacting with different things. Like, you know, let's say you wanted one to help you with your math and you were like, oh, but it always gets addition wrong. You could connect it up to a calculator, right? So I'm also aware that there isn't a stream after this. So if people want, I can overrun a bit. Can't overrun too long. The next stream is in an hour and a bit. That will be today in Global Hack Week for day 3, and I will be there again, so you can come and chat to me then too. Cool. So what we're doing right now is we're loading the model, and hopefully all of this is fairly familiar to you. We're kind of just putting things that we've already done into place. And so none of this is like super new. It's just we're putting it in. Oh, let's get that right. LM. Right. Looks like it's a bit unhappy. Never mind. So yeah, hopefully none of this is like scary because what it is just stuff we've already done. Yes, good question. The streams will be available. You can check out any stream from any Global Hack Week. They're there forever on YouTube. You go to MLH, go to the live section, you can scroll back through them all. So yeah, check out maybe some of the stuff on Cloud Week as well if you're interested in like the deploying side of things. I'm almost certain that someone did one, if not a series of streams on like deploying AI to the cloud. And I imagine like, you know, running off like cloud compute and things is something that was covered because it would be weird if it wasn't. But yeah, so you can check these out at any time. And hopefully, if you want to rewatch this one, it will be helpful again. But what I will do at the end as well is I will share some resources which explain some of the stuff which I've talked about really well. So if there's any things which you've gone, oh, Quinn was rubbish at explaining that, I don't get it at all, that's totally okay. I'm learning too. And these resources which I've managed to pull together should have everything that you could ever want to learn. So how much have we got? Okay, we've got about 10 minutes. I'm going to do a shameful thing. And I'm going to copy and paste the rest of this file because I have prepared this in advance. Yes, I know. And so I'm sorry for those who've been typing along in a dedicated way. Ooh, let's get that right. Typing alongside, but I'm going to shamelessly copy and paste. And I'm going to make sure that I don't copy bits which I've already typed, because otherwise that would be super confusing. And hopefully it will work. Right, okay, cool. I will talk through all of this though. It's just because my typing is a bit slow. Right, let's get this incorrectly. Have we got... Here's the concern where we say like, Quinn has renamed things differently. That looks good to me. Okay. Yeah. Okay, I think that's looking fine and like it's going to run really well for us. So I'm going to run this cell, and what it's going to do is it's going to create us an app.py just over here. At least I believe it should, unless it puts them somewhere else. Yeah, okay, there it goes. You could equally like have like a utils folder and put all sorts of different things in. You can make this a much bigger project. Like I'm making it basically like a one file wonder, but you could flesh this out a lot more. I wouldn't recommend running it from Colab like as your like final solution if you wanted to actually release something like properly and have it running all the time, because Colab it times out after 3 hours. So it won't be good for that. But there are like a bunch of other solutions for this kind of thing. You can get some pretty cheap compute to run this kind of thing online. So there are options. I just threw in again, like, sorry, I skipped over that maybe, and actually I didn't talk through the file as I said I would, so I'll do that first. So let me hop back. Don't want to jump ahead. Okay, so we're loading the model here, right? We're familiar with pretty much all of this. Like as before, we're basically compressing it with bits and bytes. We love it. This is why you need to use a Linux system or do some kind of like slightly janky stuff to get it working. It will work fine in Colab though. If you wanted to run it locally without bits and bytes, you could, but you would need a humongous GPU. And then we are saying, okay, if we've said, yeah, use the entity personality, that's the one that we're going to load. Otherwise, we're loading the base model, which is just this here, right? So you can see that the model that we've trained using LoRa is an adaptation to the base model. It's like something we've kind of clicked onto the weights to just adjust things a bit, right? And we can see it worked kind of like really well. If anything, it maybe worked too well, and the personality is extremely strong. So there's maybe that, but we're going to be able to switch between personalities and actually see the difference, which is going to be cool. And then what else are we doing? We're loading everything. We've got a little spinner going up, so as the user sits there, they're not kind of confused what's happening. And then we've got a little place where we're going to ask, basically this is like our chat window saying, oh, what do you want to ask of the entity? And then when you click the button, consult the Oracle, it will take in your input. And it will, I don't think we should have 2 slashes there. And it will give out the output, and hopefully it will be nice and hunky-dory. As we can see, we're also using some of the other variables that we defined. These are going to be toggleable, and this will kind of become clear, but we're updating the arguments on our in our pipeline, basically, based on whether or not the user it changes them, it turns them on or off, whatever, right? So it's nice and flexible. And then we're splitting on the output, right? So we're basically reformatting the response to make it nicer. And we're cleaning up. Nice. So I think that makes sense. And then we install all the bits and pieces. There's nothing new here, really. This is a tool which we can use for ragging. Like I said, ragging is for knowledge retrieval. So if you've got a predefined background, let's say you've got a character that you want your user to interact with, and that the user needs to try and get this piece of information out from them, right? Maybe they're exploring and they need to find some knowledge about, I don't know, some lost city, right? And you want that to be a consistent thing which the model will talk about. Well, you can have a lore document, and if you go to the data tab in that GitHub, which I linked earlier, I'll pop the link in again in a minute. I've actually got some lore files. These are, I mean, they're again generated by ChatGPT, so they're kind of like mostly full of like background information or whatever. And in theory, you could set up ragging using this, which is basically, I'm not going to get into it because I've run out of time, unfortunately, but I'm happy to do a future session if people are interested in this. But what it basically does is it goes through all of the lore files. It picks up the most relevant bit based on like kind of semantic similarity, so the kind of meaning behind it and what's most similar to the input, the prompt that the user has put in, and then it will throw that in as the input, right? So what we have, instead of having a blank input, we put that in. Now, predictably, that doesn't actually work very well because we've trained it on an empty input, right? And so the other fine-tuning data set that I've got in there, it's labeled something like instruction-input or something. It does have inputs. It's much shorter as well. I haven't actually tried it. It's only like, I think 100 observations instead of 400. Hopefully that should be enough, because as you can see, like as we will see, the personality on this one is really strong. So less data will make it less impactful. But I mean, even with tiny amounts of data, we've had some like really big success. So if you want to have a play, that would be my recommendation. Try exactly what we've done, but fine tune it on the other data set. See how much the difference in size, the difference in number of observations makes a difference. And then maybe go, okay, can we rag it now? Because now it's expecting an input. What difference does that make? And hopefully it will have some lore which it refers to, and it will talk about that lore. Again, like I haven't tried that with this little project, but maybe I will actually. I might at some point like host this somewhere. So if people are interested, I'll maybe pop a little message down in the Discord, and people can check it out. Awesome. Okay, cool. Nice. Now, what I'm going to do is I'm going to run this. I'm going to run it with ngrok, so you all can check it out. And again, I'm sorry, I'm going to paste in code for the sake of time. That's not the code that I wanted, so we've already done that one. Sorry, friendos. I know we're getting close to time, so if anyone wants to give feedback, if anyone has to go soon and wants to give feedback, the link is, I will throw that in the chat in a second, actually. First, I'm going to run this. The important thing to note is that ngrok is going to have a little tantrum if you don't have an auth token set. You can do that in Colab using user data. I've set it in here in the secrets. I'm not going to reveal mine, but you can just add a new secret and put it in. So, I mean, there's like loads of different ways that you could do this. You could also just paste it in, but I wouldn't necessarily recommend doing that, especially if you're going to like commit this, right? Think about API keys and so on. But this is free. ngrok is free, so we like it, and we're going to run this, and hopefully it will work. It's saying, oh, it doesn't have secret access, so we're going to give it secret access. And now I'm super sad because it's looking like it's erroring. Yep, okay. It timed out. I'm just going to run it again and see what happens. It seems strange to me that it timed out. I'm going to be really sad if we, okay, yeah, there we go. Right, okay. So now I'll paste this link in the chat in a second, presuming it works. If it doesn't work, then maybe I won't paste it in the chat. So we're going to have a super simple, hopefully a functional and super simple UI. And it's just loading in. You can see up here it's loading. This is like minimal, very basic Streamlit stuff. But I do like Streamlit. It's good for hackathon projects because it's so quick to get. I mean, you could sort of like, I barely had any code for the UI. I mean, literally none, at least on the front end. Okay. Delta generator object is not callable. Now we've got some real fun because we're debugging under pressure. I do have multiple collab files open, which I don't normally, so that could be what's causing some problems. Okay, what I'm going to do, again, somewhat shamefully, is I'm going to copy and paste the full app .py that I used when I did my run through, because I know it works. So you might see some slight changes. In fact, what we will see is the attempt at ragging. In fact, I don't know if this is going to work because we haven't uploaded the files. So you can see here we've got like some of the law retrieval stuff. This is like pretty heavily commented. So hopefully, as I scroll past different bits and pieces that we haven't had the time to do, it's going to make sense. So my main concern is it loading the law. Yeah, it's gonna be a bit sad that we don't have. We can try it actually. It might just say we don't have a file and then still kind of run. It probably will get upset that we don't have a law folder. If it does, then we'll quickly make one maybe. Nope. Okay, it's happy. Cool. Well, happy for now. While it's loading, I will quickly pop in mlh.link. I'm doing this from memory, so I really hope this is the right link. I'm pretty sure that is the link for the feedback. Okay, you can see like some slight UI changes here where I played around with it a bit more. Let me know if that feedback link doesn't work, by the way, and I can hunt out the correct one, but I'm pretty sure that's right. So we set this little spinning thing to load. That's in the file as well. You can scroll back up and check out this notebook still because it should still be shared, and I'll leave it open for view only for anyone who wants to check it out. It's taking a little bit longer to load the model than normal. Now it's running load law. This is where it might break because we don't have a law folder. Yeah, okay. I was hoping it would be intelligent. Okay. You know what? I've got 1 minute. We're going to upload the law folder. We've got time. We've got time. We can overrun a bit. So I'm sorry for everyone who has to head off. Can I upload the whole folder? No? You should be able to, right? Oh, sorry, that made a loud noise for me. This is where my immediate knowledge of collabs starts to get less. Like playing around with this kind of thing is not something that I do that often. Okay, so we made a law folder. This is good news. Let's upload the law files now. So after all, we are getting to do this bit, which is super fun. So those were that was the second data set, by the way, you can try out. This is like some markdown and some text files for the law. And I'll show you how it kind of doesn't work because of the way that we've done the fine tuning, right? All right, and if we run this again, so it's going to kill the previous tunnels. If you are using ngrok for free, you have a limit of 3, which is why I have that little line there. And then this time, finally, the link is correct. Oh, thanks, Wei. So yeah, anyone who wants to give feedback, I really appreciate it. This is only my 3rd technical stream, so I'm still kind of getting the hang of things, especially the pacing. If you want it to go faster or if you want it to go slower, I'm aware that, especially compared to some of the other coaches, my workshops can be a little bit more theoretical and maybe less programming heavy. So I'm happy to kind of like make a change to that if you want. Oh no. Oh no, I'm really sorry. What's going on here? Okay. I'm going to give us till 10 past, and then I'm going to cut us off. I know there's no one after me, so there's no stress. There's no stress. You're not missing anything. Right. Oh, I'm being really stupid. Okay. Can I just click and drag? Yeah, nice. Okay, so I think it's actually that didn't seem like the no such file directory law. Oh, it's case sensitive. It's case sensitive. No, you know what I said earlier about yeah, there we go. There we go. Okay. This time, these are the kind of like silly little mistakes that I make so often. I think I said it earlier that, like, you know, in like a maths test when you like accidentally write a plus instead of a minus, or vice versa. I do that all the time. Okay. Okay. Yeah, thank you, chat. Lowercase l, so true. Although I didn't move the files in either, so that still would have been strange. I don't know how rigorous I was with writing that function. So it might have been fine that there was nothing in there. Okay, cool. Okay, right. Who are you? And we'll consult the oracle. And it's thinking. So this is the bit where sometimes like ChatGPT will generate like a word at a time to make people less impatient, but it does everything all at once. Okay, so what it's doing is it's using the law, and it's using it pretty badly. You can see that it doesn't really understand how to use it. And this is because how we trained it, right? So sometimes when you're fine tuning, you have to think a little bit ahead, like, oh, are we going to be ragging it? Are we going to be having an input? We didn't train it to have an input. And then we've given it an input, right? So when we use ragging, we are retrieving the most similar data. So it went through the files, and we have a file on like background. In the law section, we've got a file on like the background, a character background, right? And so somewhere it will say, and we can actually run this again and click show law, and it will show which law has been retrieved. So this is, there we go. This is it's retrieved this from one of the files. I don't know which one, but this will be like directly from one of the files. And then you can see here it's like potentially using some of it or potentially not. It doesn't really understand because we've given an input and it wasn't trained to have an input. But if we disable law and then we say this, we're going to get much more normal responses because this is what we've trained it for. So this is why I gave the other data set. If you want to try ragging, you want to try with inputs as well as instructions, you can. And this is much better. We're still having this problem where it's kind of going on too long and we're cutting it off. And you can improve that with like some of the pad tokens and things I spoke about. And again, like we can switch this off and it's going to load in the new model and tokenizer. So this is going to be a bit slow. You could have all of the models loaded. That would take a little bit of time at the start and it would use up much more VRAM. So if you wanted to have like multiple things at once, multiple like LLMs all at once, you're going to have some hardware restrictions maybe. But if you have like an RPG kind of style story where you're only having one or maybe two characters talking at a time, this is like really great because, you know, if you have like cutscenes or, you know, whatever, like animations and things to transition, this loading can happen in the background. And now it's loaded and we're going to ask it again, who are you? And we didn't update this, so this should be saying Phi2 is considering. And this is actually a much better response than it was giving us earlier. So this is what I was saying, like if we run it a few times, it might give a better response. But if we run this again, we'll see what Phi2 says. And this is actually because before we didn't have sampling enabled, but this time we do. So it's giving us different responses. It's better than what it was by quite a long way. But at some point, if you run this enough times, why has it said this? So this is, by the way, this is Phi2. This is not the entity. This is not the one that we fine tuned. This is the default, right? So you can see how like kind of temperamental it is. It's referring to bits and pieces of its training data. It's not consistent. Look here, this is what I wanted to happen. It says it's made by OpenAI. How much time we got? We got a couple of minutes. It says it's made by OpenAI, but it wasn't. Phi 2 was made by Microsoft, and this is because it was trained on data generated by OpenAI. So it's learned this. It's learned that ChatGPT or whatever it was trained on, whichever model, says this, right? One of OpenAI's. And it's gone, oh, I'm made by OpenAI. But if we run it a ton of times, probably at some point it will say Microsoft. Maybe at some point it will say Meta. I might have some training data from Llama. We don't know, right? But by enabling this personality, oh, it's already loaded. Huh? I didn't realize it kept it cached. I thought it replaced it. That's my bad. Yeah. By doing this, it's much more consistent. And we could ask it a bunch of different things like, how do I open a PDF? This is actually in the training data. And it's going to give like some pretty wacky responses, but it's super fun, right? You can have a play around with this. Let me actually, right now, while it's loading, if you want to check this out, I'll leave it running like for 20 minutes or so after this stream ends, and you can have a little try. It might eventually like crash because too many people are trying it, or because it's been running for too long. We're probably nearing 3 hours. There you go. So this is not the exact response in the training data. I know, because I remember seeing this training example, which is good because it means it's not overfitted. It might be a little bit overfitted, but this is like pretty good. It's pretty coherent sentences, and it's answering the question. I mean, it's it's saying kind of like slightly funny things, but it's got some kind of like personality, right? If anyone's got a question they want me to ask, I can ask it now. Maybe we'll say like, oh, I need a good question. Okay, what's your favorite type of juice, right? We were asking this at the start of the stream. Let's, oh, now that's a good example of something which, you know, if you were building a proper app, you might want to make better, right? The user experience on this is reminiscent of you know, my preference against like front end, even like full stack development. It's not really my gig. I'm much more like the ML engineering side of things. So, but yeah, if you were building this into a full app, right, you might want to have some like slightly nicer user experience stuff. You would want to have like something to make this not so painfully long for the user. So there are considerations. There are definitely like a lot of improvements. And then after this runs, I will show you what happens if we like crank the temperature. There we go. The entity loves citrus-infused silence, the one that ends on a sigh and not a crash. We favor a blend named Kronos. It tastes like a rainbow in a forgotten dream, and it kind of just like, we are still trying to smell our way out of it, but you won't regret the taste. Just remember that things can blend. Well, sometimes they explode. Like you can see it kind of gets like a little bit crazy, and that's because of how we trained it. That's the style of, like, if you read the data that we trained it on, it's all rambly and confused, right? So this is kind of fun. But if you wanted to, like I said, have a sales bot with really formal professional language, you could do that too, right? As long as you've got the data for it. And hopefully those data sets which I shared are helpful. None of them are really geared towards personality like training, but they could be. So let's, oh, we limited it to, that's my bad. Let's just crank these all the way up and then see what happens. So hopefully this will be a little bit more out there, because we're not restricting. We're saying you can have 100 of the top tokens, and we have doubled the temperature compared to what the normal probabilities are. So it should be like a bit less sensible. So you can see here, bitter ginger root filtered, slightly earthy. That technically makes sense. Well named, you have more respect for names for which code sneezes out gracefully. So you can see it kind of like, it's not as coherent. It doesn't make as much sense. If we made the temperature even higher, you could experience that. If we put the temperature down at 0, it should error actually. I don't know if we handled that in the function. So I'll put it like really low. And if we ran this a couple of times, we would get pretty much the same response every time, or that's what we would expect. You can also disable sampling, and that does the same thing as lowering the temperature to 0. So if we run that again, hopefully we'll get something, you know, the one that tastes like a memory you forget. Hopefully we'll get something like similar-ish, but we might not. Yeah, okay, there we go. This is not the same, but it's very similar. You can see the effect of lowering the temperature, right? So the temperature basically restricts the probabilities that we assign to the tokens that we're gonna like output. So I hope this is like satisfying. I'm gonna wrap up. I'm sorry we finished a bit late, but I hope it was really useful. I'm super hyped to see a bunch of people have stuck around for the full thing. I hope everyone's really enjoyed it. Yeah, and I hope it's been interesting. I hope with the kind of intuition for like how fine tuning works makes a bit of sense. Hope that you've enjoyed learning how to do it with like minimal hardware. And again, I hope that you've managed to get something working yourself, or that at least you managed to check out mine. And again, my GitHub is out. You probably have to play around with it a little bit to get it working in Colab or your own local environment. But the structure is there, right? The bulk of it is there. You can try different data sets. You can try different models as well. Most of them will take a lot longer. We spent about 10 minutes training. Most of them will take a lot longer than that. But I hope you've had really, really good fun. I hope it's been inspiring, and I hope you want more, because there is more to come. Today in Global Hack Week is in 50 minutes. Yes, 50 minutes with me and someone else. So that's an exciting surprise for anyone who wants to join and learn about what's coming up tomorrow for day 3. And yes, finally, please fill out the feedback. I'll throw the link up on the screen, and I'll leave the stream running for anyone to grab that link for the next few minutes as well. But thank you very much for coming. It's so cool to hear that you've had good fun. So yeah, please let me know if I can do anything better, if there's things that you liked. And until next time, thank you very much.